Okay, I'm going to explain this problem, 8 plus 3n over 12 equals 13, from our 4.2 multi-step equations homework, and I'm going to try to explain it in two different ways to help you understand the process of solving multi-step equations. So to begin this problem, we notice that the variable n is here. It's on the left side of the equal sign. And our job is to do the opposite operations to move all the other numbers to the other side of our balance, to our equal sign. So our procedures are to always attack the addition-subtraction number first. We looked at that yesterday, and for now we'll just call that the procedure of solving multi-step equations. So we're going to do the inverse operation, or the opposite of plus 8, which is minus 8. And we'll do the same thing to the other side to maintain balance of the equation. Now we'll simplify both the left and the right side. So all of this, minus 8, leaves us with 3n over 12. A plus 8 and a minus 8 are 0. I combined them because they're like terms. And 0 plus this just leaves us with that. These cancel. On the right side, we have 13 minus 8, which is 5. Now, the first way I'm going to approach this problem is to deal with the 3 and the 12 separately. I still have my n equals here. I have a divided by 12, and I have a times 3 that's being applied to the n. So step by step, I will deal with them as such. I'm going to work on the divided by 12 first. The inverse of divided by 12, or the opposite, is multiplying by 12. So I'll multiply this side by 12, and I'll multiply this side by 12 to maintain balance. Now, I could also think of this as 12 over 1, since I'm multiplying a whole number by a fraction. And those of you that remember 5th grade multiplying fractions may remember that you can cross-cancel common factors. So we now have 3n over 1, which is the same thing as 3n. Another thought is that multiplying by 12 and dividing by 12 are opposite operations. They'll cancel each other. There is another thought of that cross-canceling because of multiplying fractions as well. Either way, we're down to 3n equals 60. And then we will finish up by dealing with the multiplying of 3. This says 3 times n, so the opposite operation is divided by 3, and we'll divide by 3 on the other side. Notice again that I'm using a fraction bar to represent division. 3 divided by 3 is 1, and 1n is simply n, equals 20. So I know that I'm finished because my variable is isolated. Up here, it was surrounded by numbers, and through a slow, methodical process, showing my work with each step, I now have n equals a number. So I know that this is the answer to my equation. Now, to plug this back in is using the substitution problem. I would have 8 plus 3 times 20. I'm just going to go ahead and write that as 3 times 20 is 60 over 12 equals. 60 over 12 is the same thing as 5, and 5 plus 8 is 13. That's what I wanted. So my check is complete. Next, I'm going to solve this in a slightly different manner. There's a couple of different approaches to how you can solve this problem. I'll begin the same way by subtracting 8 on both sides. That's not going to change. When you deal with a multi-step equation, you attack the addition-subtraction part first. I should say most of the time. There are some occasions when you don't. We'll look at those in a future time. So again, 8 minus 8 is 0. 0 plus this just leaves us with the 3n over 12 equals 5. That didn't change. However, I am now going to change this. I am not going to do step-by-step procedures. I am going to rewrite this as 3/12 n equals 5. Writing a variable in the numerator and writing it next to the fraction is algebraically equivalent. It's the same amount either way. I've talked about this in the past, but if you'll, well, I'll just do it right here. 3n over 12 is the same thing as 3 times n over 12, which is the same thing as 3/12 times n over 1. Think about it. If you multiplied straight across, you'd be there. And that's the same thing as 3/12 times, a number over 1 is just the same thing as that number, which finally leaves us to 3/12 n. Putting a dot or smushing the two things next to each other are identical. So there is a quick algebraic explanation of why I can go from there to there. This is a fraction, and it's not in simplest form. So the next thing I could do is simplify 3/12 into 1/4. Divide by 3, divide by 3, 5th grade math. 3/12 is the same as 1/4. And finally, I will multiply the 1/4 by its reciprocal, 4/1. A number times its reciprocal is 1. That's the multiplicative inverse property. I'll multiply this side by the exact same thing, only I'll call it 4 this time because I'm not multiplying by a fraction. 4/1 and 4 are equivalent. So I once again have a number times its reciprocal is 1n, or simply n, equals 20. 5 times 4. Two explanations for the same problem. Whichever way helps you think about it best is the way that you should plan on working on these. I would suggest that this one is the more advanced way to do it, the shortest amount of steps. But if you need to do it piece by piece for a while until you get the hang of multiplying by the reciprocal of a fraction and learning that this and this are algebraically identical, then that's okay. Thanks.